Hello, everyone. I hope you all are doing well. This side Priya Bhatia, and I hope that I'm properly audible, properly visible to each and everyone. As you have already have seen from the thumbnail headline as well as the thumbnail itself, that today we will talk about the NumPy. So before we will start the session, I will wait for a few minutes so that everyone will join. In the meanwhile, if you guys can confirm to me that whether my voice is properly audible or not, then it would be a perfect start for our session. So can I get some confirmation from those people who have joined me live that whether my voice is properly audible or not? Uh, Meanwhile, I am just checking it up. Okay. So hi Ravindra, how are you? So he said it's audible, all clear. Perfect, perfect. So that's superb. So what I will do is I'll try to share my screen in the meanwhile. A very good evening to all. A very good evening, Ganesh. So what I will do is I'll try to share my screen and then maybe those who are joining in the meanwhile they can join. So let me share my screen as well. Okay. So is my screen is properly visible to everyone? Is my screen is visible? Black screen, code screen. I think everything is visible, right? So this is the today's objective where we need to cover up the mastering the power of NumPy. So we'll talk about the NumPy here, and we'll see in a lot more detail that what is this NumPy all about. What is the full form of this NumPy? At what point of time we should talk about this module, right? And we'll try to discuss few functions which are very very important to understand in the NumPy package. So we'll try to explore all those functions that we have, and later on if you have any sort of doubts, or in the meanwhile also if you get any sort of doubts, you can ask from me. That's the only objective, to discuss the session live so that I can also see your doubts on the spot and will discuss with you. Okay. So I hope that those who want to join me live, they can join. I can also send the notification on my WhatsApp channel group. Just give me a moment. In the meanwhile, if you have any sort of questions, anything you want to ask from me, you can definitely ask. Okay. Perfect. So let's get started with the very first concept of this NumPy. The very first question is, what does this NumPy came from? Anyone who is already aware about the full form of this NumPy? Anyone who knows what is this NumPy all about? Hmm? Anyone who is already? Yes. So as said by Ravindra, so whenever we are talking about NumPy, whenever we are talking about NumPy, so it composed of two components. Num means numerical, py means Python. So it is nothing but numerical Python. Okay, numerical Python. So basically, whatever computations we want to do, all those computations numerically in the term of arrays, metrics, will be easily done whenever we are using this module of NumPy. Or in other words, I can say that this module is completely designed to do the numerical computations much faster in a highly optimized manner. Okay? So that is where this NumPy package came into picture. Now, you will ask me that what is the real life application of this? We are studying this, ठीक है, but कहाँ पे हम इसको use करते हैं? Where we usually use this kind of a things? See, if you are specifically from a data science domain, or if you are, trying to go into this domain, at that point of time, you already been aware about the fact that, whether we will be talking about images, whether we will be talking about data, whether we will be talking about videos, right, audios, right, images specifically, which complete domain of deep learning, many people in the healthcare, many people in the different domains are working with the images part, object detection. There are so many applications we have. Now all these images will be always designed in the form of a matrix, where we will be having something called as a pixel value, where we will be having something called as a pixels value. So what I mean to say is that whether you are dealing with the images, whether you are dealing with the videos, whether you are dealing with the audios, what usually happens is that as a human being we see a image, but internally that image is a matrix only of whatsoever dimension picture you are taking up. For example, that image is a RGB image, so it is having a three channels. If it is a grayscale image, then it will be having a one channel. So what I'm saying is that every image internally, when you're using that image in order to process that data, in order to get the inference from that data, you are anyhow dealing with a matrix, you are anyhow dealing with a 1D array, 2D array, 3D array, and so on. So that's where you have to use something called as a NumPy package. You can directly use a normal array also, a list also, that we have in Python. But when you're talking about NumPy, internally they have already written an optimized code, which is very much helpful for a developer per se, that he or she can write directly a code and directly can use the functions that we have in a NumPy, and he will be able to get the direct results in a very efficient manner. So that's where the need of this NumPy module and understanding of that NumPy module will come into picture. I hope it is clear to everyone. Shall we move ahead now? So the very first thing that you will observe here, that when you're doing in the local environment, you have to obviously install Conda, install NumPy. But because I'm doing in the Google Colab, so what you have to do is you just need to import. You just need to import something called as a NumPy, and you need to give the alias name as np. You need to import the NumPy and you need to give an alias name as np. You can also use NumPy at every place, but np is a short, you can say, name of that NumPy, which I will directly use in order to do anything, any task of mine. So what I will do, I'll directly import that, right? I'll directly import that. Now here, if you will observe, once this part is done, so it is connecting my file, so it will take few amount of time, and then it will be done. After that, let's run it. Okay, it is connected now. Here, if you will observe, let's say I will take one array. So how basically we can create any 1D data in the form of an NumPy array. So you need to take np.array, and inside that you can pass a list of numbers. For example, let's say you will be having 1, 3, 4, 7, 9. So if I'll just try to run this, and if I'll just try to print this array, what do you will be able to get is, you will be able to get an array which compose the numbers like 1, 3, 4, 7, 9. If you want to check the type of this array, so I hope everyone knows now, those who are following the playlist of Python programming, at least I am expecting from them that they already know that how basically we need to check the data type of an array. So here you will observe that this is nothing but is a ND array. So always remember that in NumPy, in a NumPy, whatever array you are trying to design, its type is ND array. What is the full form of this ND array? It's n dimensional array. It's n dimensional array. It's n dimensional array. Is this clear to everyone? So it's an n dimensional array where we will be having 1D, 2D, 3D, and so on. Okay. Let's say you want to create a 2D array. You want to create a 2D array. So maybe AR2, where what you want to do is you want to create a 2D array. So 1, 3, let's say this is the first array values you have, then 4, and then 7. That's it. So this is the AR2 that I have. Now if I'll just again run this, and if you will check this particular AR2, and if I'll just again show you what is the type of this AR2, this is something that we have is again ND array. So this is a one dimensional, this is a two dimensional. Similarly, we can create a three dimensional, four dimensional, and so on. What happen if we only write numpy? So if you just only import numpy, so what will happen is at every place wherever I am just writing np, you have write and numpy full name, you will be able to write. It's just like that. For example, my original name, my professional name is Priya, but let's say at my home, my dad, my family members used to call me maybe Priyanka, let's assume. So Priyanka is my alias name, but Priya is my professional name. Similarly, here numpy is the professional name, np is the alias name, but both of them are doing the same task. So if you will not write it as np, and if you only import numpy, at that point of time, wherever I'm writing here np, you have to write numpy. That's it. That's the only difference or the change you will be able to get. Internally, computation wise, everything will remain the same. I hope it answers your question, Harsh. Okay, now let's move ahead. So here we have seen what is 1D array. We have seen what is how the 2D array will look like. I'll try to create one more 3D array, and I will try to show you how 3D array will look like. So let's say I will be having one more array, add 3, and there I will start with 3 brackets. I'll start with 3 brackets, if you will observe. Okay, this is the first thing, and then I'll try to create one more set of values, let's say 2 comma 4 and 5 comma 7, and the complete bracket will be done. Now this is an area where many people get confused. That's why I'm trying to explain you in a very clear detail with the implementation. This is something which we have as an example of a 3D array, where again if you will type the add 3, you will be able to get the similar answer, but here the number of dimensions will be nd array. Now it will be 3. In the above case, it will be 2. In the first case, it will be 1. Now you can ask from me that how basically I will get to know. One way is to check the brackets, number of brackets, number of starting brackets you can check. There is 1 bracket, means 1D array you are dealing with. 2 brackets, starting bracket, 2D array you are dealing with. 3 brackets, your starting bracket, 3D array you are dealing with. You can also check it out by the methods we have. Add 3 dot. So here, I think we have a method of d min, if I'm not wrong. Let me check it out. Let's run this. We will get some error. Yeah, it's not correct. D I think there is a method that is, I'm pretty sure. Let me just check it out. So this is the benefit of doing it in a Jupyter notebook. There, if you will tap on tab button, you will be able to get all the functions. I think ndim is the value. Let's see. Yes, I think yes, it is correct. So here what will happen? If you will try to check it out the number of dimensions, you will be able to get the number of dimensions as 3 in this case. If I will tap on with respect to R2 and will check the same thing, ndim, so you will be able to get that here we are dealing with the 2 dimensions if you want to check it out. And if I'll just go and tap on here, what is the value of r dot ndim, then you will be able to get a next array dimensions as 1. So here we have an example of 1D array. We have an example of a 2D array where we will be having rows and columns. And then we have an example of 3D array where we will be having rows, columns, and how many number of values you have. Now, let's say you want to check the shape of your array size. You want to check the shape of your array size. So there exists a shape function which you will have to use. Add 3 dot shape. If I just run upon this, you will be able to get the answer as 2 comma 2 comma 2. It's very easy to get the shape in the 1D array understanding. If I'll say add dot shape, you will be able to get an idea that, it's a five values are there, 1 2 3 4 5, so you will be having 5 rows and there is no as such column you have. If I'll tap on about the add two dot shape, add two dot shape, if I'll just run this, you will be able to get the idea that here we will be having 2 rows and we will be having 2 columns. We will be having 2 rows and 2 columns. That's what you can see here. It's very easy to understand, right? I hope everyone will be able to get the understanding. But anyone who can tell me what this add three dot shape is representing? So I hope this is very much easy for everyone to understand that whenever we are writing a 2D array form, let's say you will be having 2, 3, 4, and 5. In this case, let's say we will be having this array. In this case, let's say we will be having this array. You will able to see that here what we have is we have a value of 0, 1. We have a value of 0, 1. So this is a row and this is a column that we have. So we have 2 rows, we have 2 columns. So that's why it is 2 comma 2. But when you're talking about this 3D type of array, three-dimensional array, your answer is 2 comma 2 comma 2. What is this representing? Anyone who can have the answer? So here if you will see, you always start from the very end. Always start reading from the very end. This is where many people get confused. That's why I'm trying to stretch upon this thing, that how basically you will be able to learn this understanding of add 3 shape. Always start from a very scratch, very end part, which is 2 comma 2. So this part indicates that what is the size of a matrix that you have, 2D matrix that you have in your add 3, which is 2 comma 2. Here you will see you will be having 2 rows individually and 2 columns. That's why it is 2 comma 2. This is also 2 comma 2. And how many number of values you have inside this? How many number of 2D 2 comma 2 matrix you have? It is 2. This is the first one completely. This is the second one completely. That is the understanding of add 3. Is this clear? Yes. There is a 2 matrix as said by Jubair, that this simply indicates that we have a 2 matrix size, 2 rows, 2 columns. Let's say if I just do the some sort of bit of changes here. Let's say if I'll say I will be having, let's say, add 4, and here let's say what I will do is I'll try to take one more combination of 2 comma 6 followed by, let's say I will be having 4 comma 7. Okay, and that is something which we have is add 4. Let's see whether it is working perfectly fine or not. Oh, add 4. Perfect. Now if I'll ask you, what do you think add 4 dot shape will return to me? What do you think add 4 dot shape will return to me? Any answer can I get from anyone? If I'll do add 4 dot shape, what do you think is the answer we will be able to get here? Anyone who can let me know with respect to this particular part? See, many people I am saying will get confused in these things. Even if you will ask from your friends about this, see, NumPy is all about the matrix computation. And if there is anyone who is not good with the matrix part, who is not having a better understanding about how 1D array, 2D array, 3D, 4D will work, in terms of visualization also you have to explore in this context, right? You will not able to get the understanding of this session. Yes, as said by again Zubair and Ravindra, that it is nothing but will show to us the 3 comma 2 comma 2. Why? Here if you will observe, you have to start from a very end. It is 2 cross 2 matrix, and there are 3 values, 3 metrics that we have. So if you just run this particular thing, you will be able to get a better understanding that it will be 3 comma 2 comma 2. I hope this part is pretty much clear to everyone. So until so far what I have explored in this session, we have talked about what is NumPy, what is numerical Python, basically who are the people who should definitely work upon this learning library, because without this you will not able to do the computation of a matrix. What is a real-time application? We have seen that whenever we are talking about images, whenever we want to deal with the data of videos, audios, everything, if you will observe, internally will convert into a matrix form. We have to deal with that. To deal with that, we should have a better understanding of NumPy. And that's where we start our implementation, where we have talked about till now what is 1D array, how we can form that with the help of NumPy. What is 2D array, how we can form up with the help of NumPy. What is 3D array, how we can form up with the help of a NumPy. I hope this part is clear to everyone. Shall we move ahead now with respect to understanding the another amazing functions that we have in NumPy that you will definitely explore whenever you're working with any kind of project in data science or data analysis. Shall we move ahead, everyone? So again, this is again a part of your Python programming playlist. So for those people who might miss the today's session, again I am requesting, please go to the Python programming playlist in my channel and try to explore these videos. You will be able to get the recordings of each and every video, and try to watch all the recordings in the sequence fashion, because now we are moving towards intermediate to advanced level in Python. Already we have covered up the basic to intermediate level of Python, and I hope that those who are following from the very first video of mine in the Python programming playlist, they will be able to now get the better clarity of what things we have in Python and how basically we can do the programming of that. So shall we move ahead, everyone? Now there is one another amazing function that we have in NumPy that you will very widely use. We will talk about this. We will come this array 1, array 2, array 3, array 4 again. But before that, I'll talk about few more functions that we have in NumPy, which we will widely use. In that, there is one amazing function that we call as arrange. Arrange. Let's say if I'll say that I will be having some values in this function of arrange. Maybe I'll say that I'll write some value like 1 comma 9. Any idea what this function will do? I hope everyone in Python is already aware about a range function. Range function, which basically gives us the number of ranges, right? If I like say if I'll say range of 0 to 10, so it will start giving me the response from 0 to 9. Similarly, in NumPy we have arrange function. What it will do is by default it will start giving me the values in the form of arrays starting from 1 and will go until the last value minus 1. Will go until the last value minus 1. So if you will observe, by default it will increment the value by 1 and it will give me a list of arrays of numbers starting from 1, 2, 3, 4, 5, 6 until the value of 8. Is this clear for everyone? Is this part is clear to everyone? Now let's move ahead. Maybe let's say if I'll write np.arrange, and here I'll say maybe from 1 to 9, and inside this I will write 2. What will happen? Any idea? What will happen? Any idea? Again, this function you will very widely use when you start working on in any kind of a data science project where you are trying to first of all need to explore the data, right? So what will happen here? Here, if you will observe, we are talking about a number of steps. So here you are starting from 1, then after 2 steps, you're moving towards 3, then 5, then 7. So it's a jump point. Whatever value you're typing on here, you are jumping towards that point, right? Step by 2, by 2, by 2, by 2. So 1, then 3, then 5, then 7. And why the 9 doesn't came up? Because it will exclude the last value. It will exclude the last value that we have. Another amazing function that we have in NumPy is linspace, which again you will definitely use. Linspace. What this function will do? Please try to understand. In an interview, many people will get confused between this arrange function and linspace function, and they can ask you what is the difference between these two. I'll give you another example. Let's say I will be having a value from 1 to 9, and let's say I'll type 6. What is happening? Try to understand. Anyone who can be easily able to observe what is happening here? In this case, what is the functionality of linspace? Until so far we have talked about arrange function, and we have seen that it will give the numbers in the sequence until the starting point till the ending point minus 1. If you provide the step points, it will move a jump towards that. If you will not provide, it will do the by default increment by 1. Now what I'm saying is, if let's say we are talking about a linspace function, what will happen? If I'll what it is doing? Any idea? Very good. So here if you will observe, as said by Ravindra very much aptly, if you will observe, in the very last I have mentioned the value is 6. And as an output also, if you will observe, I am getting the value as 6. 1, 2, 3, 4, 5 and 6. Can you observe? I am getting 6 values. So what is happening here, if you will try to observe, we will be able to get the 6 values 1, 2, 3, 4, 5 and 6 with the even distribution from 1 to 9. With the evenly they distribute the values so that we will be able to get the numbers, 6 numbers, whatever numbers you will tap on. So if I'll just change from 6 to 5, you will be able to get the 5 numbers here. You will be able to get the 5 numbers here in an equal distribution. I hope that it is very much clear to everyone now what is the difference between a arrange function and linspace function. Is this clear? So here we had an understanding of the difference between the functionalities of arrange function and linspace function in NumPy. Very, very important to understand. Before that, we have talked about the understanding of 1D, 2D, and 3D array in NumPy and how we can create that. Now I am moving towards the next important point. Shall I move ahead? The next third important point in today's session, which I want to cover up. Shall I move ahead, everyone? Third question, which is very, very widely asked in interview, and many people are not aware clearly the difference between these two. What is the difference between the shallow copy and deep copy in NumPy? Anyone who can tell me any idea you have? Those maybe who are from this background, have you heard about the shallow copy and deep copy? Anyone who is already aware about these concepts? So here, let's say ki I will be having an array. Um, let's say I will be having an value of R2. Okay. So if you remember, our R2 looks like this. Our R2 looks like this, right? We will be having a normal 2D array. Let's say if I will say that I will take another variable, maybe I'll take another variable which I will call it as shallow R, and I'll try to just assign the value of R2 inside this. I'll try to just assign the values of R2 inside this shallow R. Done. This is the first thing which I have done. Another thing is that I'll try to do one more thing. I'll take the copy. I'll create a copy of this np.copy, and here I'll take the R2. So one thing which I'm doing is, one way is what I'm doing is I'm trying to directly assign the value of R2 inside this shallow R. Another thing which I'm doing is I'm trying to take a copy. There exists a NumPy copy function, np.copy function, which is trying to copy the value of R2 to the another variable that we have, which is deep R in my case. Okay. Now what will happen? Let's see. Okay, it is also done. Now what I will do is I'll try to change something in the R2. Let's say I'll say that my R2 value at, let's say, 0th position contains now not 1, maybe it contains 5. It contains 5. So now my new R2 will look like something like this. Can you see the change? So what I have done is, just try to think very carefully. What I have done is, I have the R2 which I already have defined when I started this session. Now in this R2, what I have done is I have made some small change. So because the elements inside the array, we can change at any point of time. So I have changed that. Now I just want to check it out that this shallow air look like it's the same or not. What do you think? Does shallow air have the changes or not? If we change the value of R2 as I have changed, so if I just run this shallow air, you will be able to observe that the changes are reflected in shallow air. If now what I will do is, now I'll run about deep air. I'll run deep air. What do you think? If you will observe, here the changes are not reflected. So always remember, whenever we are talking about shallow copy, what it will do is it will try to change the reflected changes that you have done in the already created array. So what is usually happen inside the memory is that when you're trying to assign the values, when you're trying to assign that value in the shallow air, so what is happening? Let's say you in your memory you have already a space where you will be having an R2. Now what you're doing is you have assigned the same thing, same memory to the shallow air, right? So what is happening that when you're changing this value, automatically this part is also get changed. But when you're saying np.copy and then you're trying to pass the values that you have in the R2, means you're trying to create a separate, memory altogether, which is a deep R. So now what will happen if you at any point of time change the value of this air to, this deep air value will not get changed. That is something which you have to understand here. That is something which you have to understand here. So if in an interview someone will ask you that what is the difference between a shallow copy and a deep copy, now I think with the help of this example illustration you will be clearly able to understand or help the interviewer understand that what is the common difference between these two. So is this part is pretty much clear to everyone? Can I get some confirmation from each and everyone here? Shall we move ahead? Shall we move ahead? Okay, perfect. Now there is another interesting function that we have in NumPy, and that is all about from function in NumPy, which again is very widely asked. Okay, I hope in the last session you already have covered up about what is lambda functions. I hope you already have an idea about lambda functions. Is the idea is clear about lambda functions? Is the idea is clear about lambda functions? Can I get some confirmation? Yes, can I get some confirmation? Is the idea is clear about lambda functions that we have covered up? Yes. So here if you will observe what this from function says, I'll try to utilize that lambda function in this function. So whenever we are having the numpy value, so what we can do is you can try to use this from function. Inside that, what you are doing is you are trying to take a lambda function. Now you know lambda is an anonymous function. Let's say what I want is I want to define the values inside my matrix. Something like this. I comma j colon. What I want to do in this I and j. So I is a row index, j is a column index. I want to multiply this value of I and j. That's just something which I want to do. In which matrix you want to do the same thing? Let's say I want to do in the 4 cross 4 matrix. So what I have done is I have tried to define one function inside this numpy in the form of a matrix. What I want is I want this 4 cross 4 matrix to be having the value of I cross j. Let's see what we will be able to get. Let's see. Can you able to see the output? What is happening here? If you will try to understand here, if you will observe here, whenever I will be having a value of I and j, whatever be the value of I and j will be there, I'm trying to get the multiplication of that as an output in the form of a 4 cross 4. Can you observe this? So here if you will see, when I'm saying 4 cross 4, I hope you will be able to understand. We will be having 0, 1, 2 and 3, 0, 1, 2 and 3. You are saying inside the function that multiply the value of I and j. So what is happening? 0 into 0 is 0, 0 into 1 is 0, 0 into 2 is 0, 0 into 3 is 0. Similarly, in the column wise, you will get 0. Now 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 3, 6 and 9. So what is happening is when you are doing a complete iteration, you are trying to multiply the value of I and the value of j. So what is happening? It is indirectly, internally iterating each and every element inside the 2D matrix and will try to do the multiplication. So how beautifully with the help of a lambda function and with the help of a numpy, in this one line of code, I will be able to create a matrix and I will be able to do my task. You can do any of the task. For example, let's say you want to take the not multiplication, maybe you want to do the addition, I plus j. If I just run this, you will be able to do the addition value. You can check any of the condition as well. Let's say you want to assign any of the condition. Let's say you are saying at any point of time, whenever the value of I and the value of j will become equal, means the diagonal elements, the primary diagonal elements, uh, whenever they are equal, just directly give me the value as true or false. You will run this, you will be able to get the value as 2, 1, 2, 3 and 4. So in this way, diagonally, if you will observe, so if you will observe in the diagonal dimensions, this is the primary diagonal that you have, right? This is where if you will observe 0 0, it is equal 1 1. So this is a 0 comma 0, this is 1 comma 1, this is 2 comma 2, and this is 3 comma 3. So you will observe diagonally all these values of I and j are equal, and that's where you will be able to get the output as 2 in our function call. That's where you will be able to get the output as 2 in our function call. Is this clear to everyone? Is this clear to everyone? Can we directly multiply what? I into j? Yes, you can. But obviously, if you remember that, let's say if I'll give you this kind of a code, you have to apply two for loops, right? To iterate all the elements. And then inside that, you will write this condition of I into j. You can do that with the help of that logic as well. But with the help of this numpy, you can understand, you can appreciate that how easy it is to do this particular task, right? If we have elements in 4 cross 4, then okay, so here we are dealing with the I and j indexes. If you have the elements, then you can say arr of I, arr of j, right? I hope you all know we have already talked about array based data structure, which we call as a list also. I have already covered up that particular part in my separate video, right? Mastering data structures in Python. So how we can access them? Here we are accessing the indexes. If you want to access the element, that's where you have to define first of all inside the array arr the elements that you have. Then you have to, in order to access that, you have to mention arr of I into arr of j, not I into j. I hope it answers your question, Ravindra. Yeah, right? Okay. Any other question anyone is having? Or shall I move ahead to the next important part of our NumPy part? There exists another interesting function. So at any point of time, whenever you try to define any new function with any logic, always try to go for this from function, with the help of which you will be easily able to do that task. Now let's say you want to create one identity matrix. You want to create an identity matrix. Anyone who knows what is identity matrix? I think everyone in their lower classes or in the linear algebra classes, I think we have in a bachelor's time also, at least I do have. We discussed or we studied about this linear algebra. So in that, there is a complete in-depth topic about identity matrix. Anyone who is aware about that? Anyone who can tell me what is identity matrix? Let's say I want to create. Oh, very good, John. Yes, it's correct. Whatever he said is correct. So it's a square matrix where we have ones in diagonals, right? Do you remember that? Yes, in terms of determinant also you can explain, or in terms of transpose also you can explain. So if I'll say np dot I believe this is the function name. Let's see. Yes, this is the function name. If I'll say 4, so what will happen? Let's run this code. So what you will observe that it will automatically, this function will automatically create, this I function will automatically create your identity matrix, where what will happen is, in the diagonal part, in the primary diagonal part, so there are two diagonals we have in every matrix. This kind of diagonal where I is equals to j is something which I am calling it as a primary diagonal. And then another part is something like this. This is something that we call as a secondary diagonal. Secondary diagonal. So I'm talking about this part. This value in my identity matrix will be 1, and that's what you have observed. So at any point of time, there is a need came where you have to create identity matrix. With the help of this function, you can directly create that. Okay. I hope until so far everything is clear. So whatever things we have covered up is pretty much clear to everyone. Now I want to talk about few more things with respect to something called as a reshape function, which is somewhat confusing to many people. So this is also one of the most important function which you will very widely use in your data science projects. Reshape function in Python, very widely used. Sorry, in NumPy. So see, there are so many functions we have in NumPy. If you will check out the list of the functions that you have, you will be amazed that there are various functions that we have. But in today's session, what I'm talking about is the functions which are very widely used. Now, many people usually ask me, what is the best way to learn out all those stuffs, or where you have learned? So the best way I always refer is the documentation. So if you will go and check it out, even I can attach this link in the description of this video, you will be able to get the complete documentation of this NumPy. where you will be able to get the fundamentals, array creation, indexing, how it is done, IO with NumPy, data types, copies, views, structured arrays, universal functions. There are so many stuffs we have in NumPy. So what I would suggest is go towards the standard documentation that we have in NumPy in order to read the better understanding of this, whatever things we are covering up after this session. Okay. But here, what I'm talking about, you will be able to get all these functions in the documentation, whatever functions I have covered up. Plus, you will get more functions also. But I want to focus on the few functions that are very widely used, and that's where I'm talking about these functions. So, the very last function which I'm talking about in today's session is about the reshape function. For that, first of all, let me create one data set. So, let's say I will create one data set. Let's say I will be having a data set which is equals to, I'll create by a linspace function which I have already explained. So what I will do is I'll say linspace, and I'll try to write down the range of a function. Let's say I'll say that I want to have a values from 2 to 9, and I want to get 50 values. So what will happen? In the range from 2 to 9, it will evenly divide the values and will give me the 50 values as an output in the data set. So if I'll just show you now what and how my data set will look like, if you will observe here, we will be having 50 values. If you will count it down, you will be able to get that. So if I will show you the size or the shape of this data, you can clearly see that data.shape will give you the output as 50 comma 1. Okay, we have data set. Data set dot shape will give you the output as 50 comma 1, because you will be having 50 rows here, right? Now let's say maybe you want to transpose this data, or maybe let's say you want to uh, do some transformation in this data. It's a 1D array, right? Can you see that? It's a 1D array. Let's say you want to change it into a 2D array. How you can do that? You want to change it in the form of a 2D array. How you can do that? Or maybe 3D array. How you can do that? So that is something which we have to understand in this reshape function. Okay? So there exists a function called as dataset dot reshape, which says that we want to reshape this original size, original shape that we have. Now you have to make sure that the changes or the reshaping part, whatever you will be doing, you will make sure that you will be having in total 50 elements only. So you will do in this 50 elements that you have. Let's say I want to create a 2 comma 1 comma 25. What will happen in this case? Let's try to see. Can you see what is happening? You will be able to get two different unique values, two different unique matrices, which you will be able to observe, of size 1 cross 25. So here you will be having one row, and number of values, number of columns that you have is 25. So if you will observe here, the count of these values is 25 in one matrix. This is 25 and this is again 25. Please try to understand. You can ask me that, be that in real life, why we are reshaping any size, any matrix, anything that what we want to do in real term. When you're dealing with the images, there is a lot of convolution. In other terms, in a layman term, if I'll say, a lot of matrix multiplications happens internally in order to find out the patterns inside the images. So at that point of time, what usually happens is, you all know that whenever we are doing a matrix multiplication, we have to be constrained with the limitations, right? Let's say if I want to multiply A cross B matrix, I have to take another matrix size as B cross C. I can't take C cross B. I hope these simple rules you know. If I have matrix 1 of size A cross B, so if I want to do the multiplication of another matrix, it should be of size B cross C. Means the intermediate size should be same. So that's where sometimes if the size is not same, you have to reshape the dimensions to get that done. So that's where this kind of things will come into picture. That kind of knowledge will come into picture. So what is happening here? You have reshaped it. Now, whenever you're doing a reshaping, you have to make sure that multiplication of all these values will always make your number as 50, because in total you are dealing with the 50 values. Always remember, many people, if you will observe, many people in data science projects are dealing with this error. They don't even know how you can do the reshaping, and then they are getting some sort of error. For example, if I'll show you what kind of error they usually get, that you might also get in the initial phase of your life. I also got. So let's say if I'll say 30 and I'll just run this kind of error I hope everyone must have faced in their life whenever they did a data science project, specifically when they are dealing with the images. There is a high chances that you are having a need of reshaping, and you are getting this kind of error, value error, cannot reshape arrow of size this into this. So always make sure that whenever you are doing a reshaping, your multiplication will be exactly equal to that number, and you are creating a metric size of a dimensions which is actually equal to the size which you're trying to deal with. Okay, this is something which is very very important in today's session, I will say. So if you will ask me in complete today's session what is the very important part, I think this is the very important part where you have to very focused on, because definitely you will face a lot of difficulty if you will not able to understand the maths behind this part. Okay, so this is the overall idea which I want to give in this complete session of NumPy. So if you will observe here, in this complete session we have talked about the different functions that we have in NumPy in a great detail. I have tried to do everything with respect to the implementation per se, so that everyone will be able to understand that whatever things I am saying, how basically these things will work internally with the practical example. Now, what we can do in the upcoming sessions is I'll try to talk about pandas as well. After that, I'll take one actual data. Okay, I'll take one actual data and we'll try to use these functionalities that we have in order to deal with the actual real time problem, and that will make a very good sense. But not in the next session, in the next session, once I will be talking about the pandas, so you will be able to understand how numpy and pandas will work, because these two are very very widely used packages in Python, and I want this to be done in a very great detail. After that, maybe we will take one real time data and we will try to do the exploration part with the help of these packages that we have covered up so far. So to understand, to have that knowledge, this is the major prerequisite. So please make sure that you will watch this recording if anyone have missed the session live. I hope that you have enjoyed this session. If you have any confusions now, you can ask from me, otherwise definitely I can wrap up the session, and we'll see you guys very soon in the upcoming session. So I'll again show you the playlist where all these recordings are available, just for the illustration purpose that no one have missed this class. So here, if you will observe, this is the last part which we have covered up today, mastering the power of NumPy in Python. Again, this is in the Python programming the ultimate playlist. You can go and check it out. You will be able to get the recordings here. All the content is available in the GitHub repository. I hope you already have seen. So just few days back, I have just uh, anyhow I have to sign up. I have just signed out from everywhere, so I have to sign up in the GitHub. You can check it out, my GitHub repository. There you will be able to get uh, the complete Python playlist programming part, and you will be able to access all the things, all the content, whatever I have delivered in the session from there itself. Okay. Nikhil is requesting to take a class on pandas data frame. Definitely I'll take. These things are very very important to understand, and whenever we're talking about Python programming, I think this is a must thing which you should know. So we will try to cover up that also in our Python programming the ultimate playlist. So please, there is a humble request from my side, do share these videos to each and everyone, so that I will be able to reach to many people. As I always say that without your support, it's not easy for me to grow the audience. So that is the only request which I want from everyone. I hope that you find this session insightful. I will meet you all very soon in the upcoming sessions where we will try to talk about further things. Okay. um so there is a issue which Ravindra is saying. Maybe when we are talking about these things, then only I will talk about that stuff, because this session will not make sense if I'll talk about this. But again, it's a very common issue. Maybe you can check in the Stack Overflow. You will be able to get the idea about this, right? Okay, then is there any issue about the today's part? Whatever things I have covered up. Thanks a lot. Thank you, Nikhil. Any other issue? Anything you want to talk about? So far, so good. Okay, then. Bye bye, everyone. And a very happy Diwali to all. Maybe I will see you after Diwali. I'm not sure. So, a very happy Diwali. I hope that this Diwali will bring a lot of happiness, a lot of prosperity in each and everyone's life. And yeah, I'll see you all very soon in the upcoming sessions also. Bye bye. See ya.